Imagine a time when everything you know, space, time, even the laws of physics didn't exist. All of existence was compressed into a point, smaller than a speck of dust. From this single point, everything we see, feel, and experience today came into being. This is the Big Bang Theory, the story of the universe's birth. But what does this mean for us? What mysteries still surround this idea? While we have uncovered a lot about the universe's origins, we're still just scratching the surface. Today, we're going to take a journey through time from the birth of the universe to its current state and beyond, and we'll explore some mind blowing concepts like dark energy, cosmic inflation, and the fate of the universe itself. Before we dive deep, if you're fascinated by the mysteries of the universe, make sure to subscribe. We explore all things science from the Big Bang to the future of space exploration, and we'd love for you to be part of our cosmic journey. Don't forget to hit the bell icon so you never miss out on any of our exciting videos. First, let's clear up a common misconception. The Big Bang wasn't an explosion in space. It was an expansion of space itself. Imagine a balloon being blown up. As it inflates, every point on the surface moves away from every other point. This is how the universe expanded. Before the Big Bang, there was no universe, no time, no space, no matter. All of this was compressed into a point called a singularity, an infinitely dense and hot speck that contained everything we know today. No one knows exactly what came before this singularity, as the very concept of before doesn't apply when time itself is created in the Big Bang. When the Big Bang occurred, both space and time began to unfold. This means that time didn't exist before the Big Bang. The universe's timeline began the moment of the Big Bang. So asking what happened before is a bit like asking what's north of the North Pole. It doesn't make sense. In the first fraction of a second after the Big Bang, the universe underwent a process known as cosmic inflation. This was a period when the universe expanded faster than the speed of light. In a fraction of a second, it grew from smaller than a proton to nearly the size of a grapefruit. The theory of inflation helps explain why the universe looks so uniform on large scales today. If the universe hadn't expanded so rapidly, small irregularities in the early universe would have been far more noticeable, but inflation smoothed everything out. For the first few minutes, the universe was incredibly hot and dense. Everything was made up of basic particles, protons, neutrons, and electrons floating in a glowing soup. This period is known as the quark-gluon plasma, and it was too hot for atoms to form. About 3 minutes after the Big Bang, the universe cooled enough for protons and neutrons to combine and form the first simple atoms, mostly hydrogen and helium. These early elements were scattered throughout the universe, and as time passed, they formed stars and galaxies. After the first atoms formed, the universe entered a period known as the Dark Ages. The gas was still too dense for light to travel freely, and the universe remained dark for hundreds of millions of years. Eventually, gravity began to pull hydrogen and helium together to form the first stars giant, short-lived stars that burned bright and exploded in supernovae. These explosions created heavier elements like carbon, oxygen, and iron, which would later be incorporated into new stars, planets, and eventually life itself. Around 400 million years after the Big Bang, the first stars and galaxies began to ionize the hydrogen gas around them, creating the ionization era. During this time, light could finally travel freely across the universe, and the first visible light started to emerge from distant galaxies. In the 1920s, astronomer Edwin Hubble made a groundbreaking discovery. Galaxies are moving away from us, and the farther a galaxy is, the faster it is receding. This was the first evidence that the universe is expanding. If you reverse this process, everything points back to a single starting point, exactly where and when the Big Bang happened. But here's the twist. In the late 1990s, astronomers discovered that the universe isn't just expanding. It's expanding at an accelerating rate. The discovery of this acceleration led to the concept of dark energy, a mysterious force that makes up about 68% of the universe and is responsible for pushing galaxies apart at an ever-increasing rate. Despite its name, we don't know what dark energy actually is. Some scientists think it could be related to the vacuum energy of space itself. But for now, dark energy remains one of the greatest mysteries of modern physics. As the universe continues to expand, we're faced with the question, what's next for the cosmos? There are several possible scenarios. If the universe continues to expand at its current rate, galaxies will